AstroPictionary Concept video, we're going to go over the Algol Paradox. Here we're looking at a snapshot in time of an animation of an Algol system. On the left, we have a blue main sequence star, and in blue lettering, I'm going to label it M sub S. I'm also going to call it M sub 2, indicating that it's the secondary star. Now, this particular secondary star has a mass of 3.7 solar masses. So I will write in blue lettering 3.7 M sub sun. Now this main sequence star is in a close binary with a subgiant. And the subgiant's color is orange. So I'm going to label it S sub G in orange lettering. I'm also going to call it M sub 1, indicating it's the primary star. And its mass is 0.8 solar masses, which I'm going to write in orange lettering to remind us that this subgiant has a mass of 0.8 solar masses. Now, these two stars in a close binary were thought to have been born at the same time. And this Algol system has one main sequence star that is more massive than the evolved less massive star, or the subgiant. From stellar evolution, we know that the more massive star should have evolved sooner than the less massive star. However, in this case, we have the less massive star that has evolved sooner than the more massive star. This is a paradox. How can this be? So in order to resolve it, either we don't understand evolution, or something must be going on in this particular Algol system. We think it's the latter. Something's going on with this system. How can we end up with a situation where the less massive star is the evolved star? Let's take a look at how we may have come about with this Algol system. We start out with a detached binary, where the more massive star is on the left, and the less massive star is on the right. So I will label them M sub 1 and M sub 2. The dashed line is the center of mass, so the system is going to orbit around the center of mass. Now, with the orange or red star on the left being the more massive star, it's going to evolve sooner than M sub 2. So the evolve will take place, and the star, or M sub 1 on the left, will fill its Roche lobe, and we will end up with a semi-detached close binary. It will transfer its mass to the unseen star secondary. The reason why it's unseen is because the mass is going to come in, and it's going to slowly spiral around, filling up the accretion disk until it eventually lands on the secondary star. Eventually, enough mass will be transferred from M1 to M2 to end up with a case where M1 becomes less massive than M2. And when that happens, we have what's called an Algol system. How we resolve the Algol system and this Algol paradox is by allowing for this sequence of evolution to occur in this close binary system. So we end up with a case where M1 is less than M2. Hence the reason why I labeled the orange subgiant star M1 and the blue star M2. Normally, what we would do now that we have the Algol system in place, is we would label the more massive star M1 and the less massive star M2. But until this point in time, we call the more massive star M1 and the less massive star M2 through its evolution until the point where we get to the Algol system, where M1 is less than M2. After that time, we now switch the labeling. So on the left is the now more massive star, and we call that one M1. It was M2, now it's M1. On the right, we had that star being M1, now it's M2, and we have resolved the Algol paradox.